Good evening, students. In the last class, we discussed about the physical properties of liquids. In that, I just explained what is the properties of main properties of liquids. That means they have a strong intermolecular force, they have a short intermolecular distance, they have a definite mass, definite volume, but not definite shape. We studied that. Okay. So, except that the general properties, they have a particular physical property that vapor pressure is there, surface tension is there, and viscosity is there. So we'll discuss one by one in this class. The first one is surface tension, vapor pressure. First I'll explain vapor pressure. Vapor pressure of a liquid. Okay, so students, in this two pressures, in this vapor pressure we can easily explain the boiling point as well as the normal boiling point is also there, standard boiling point is also there. Okay, that is equal to an atmospheric pressure. First I'll explain what is vapor pressure, later I'll explain what is atmospheric pressure when the boiling point will increase. Okay, so students, if we consider any container here, a jar, this type of jar it is. Okay, so initially here assume water is there. Okay, not only water, any liquid. Okay, next here, consider equal amount of liquid here. They are in an equal range from here to here, equal. Okay, so initially students, when you start eating this, initially what happens? Assume you are eating a water. Okay, if you see that in weather, initially it starts to give a small bubbles. Later it will starts to boil. Initially by eating only, by supplying it only, it won't boil. Initially it forms small bubbles. Later it starts to boil. Okay, so what is the reason for that? Listen, if you eat the temperature, or sorry, if we eat the liquid, if we increase the temperature, initially what happens? Slow increase in the temperature of this takes place. Liquid. So then what happens? They form only small bubbles, but they won't evaporate. Understand? They are only forming bubbles. Still there is no vapors. They are not converting into vapors. They are about to boil. Okay. Later, if you increase the temperature, initially what happens? There is no exchange of pressure from vapor. Sorry, here vapor is there. Here liquid is there. Assume here empty is there. Empty space is there. If you just eat, it won't form any pressure. So then, if there is, assume this one is closed. If there is no pressure, students, then there is no condensation process. You know, so if you boil the water droplets are collected. Water vapor is collected here, and again they condense. They convert it into water droplets, and again they falls back into the liquid. Correct? If this container is closed, vapor pressures, assume just water, this is the water only. Okay? When the water boils or when the water heat, okay, at that time they form a water vapor. Those water vapor, if it is a closed surface, okay, they collected here at the bottom of the lid or bottom of the closed surface. Okay? So at certain time they condense. Understand? So when they condense, again they falls back into what? The liquid again. Understand? So at the same time, the process of vaporization as well as condensation takes place. Understand? The process of vaporization and condensation takes place. So here, what is vapor pressure? When the condensation will take place? When the vapors form at that time. If vapors won't form, there is no condensation. Understand? Here vapor forms, then only condensation takes place. If vapor doesn't form, there is no condensation process. Okay? Cannot be possible. Means What is vapor pressure means? So it is a thermodynamic, or it is an equilibrium state. Wait. The pressure exerted by the liquid. The pressure exerted by the liquid is in thermodynamically equilibrium with its equilibrium with its condensed phase. Condensed phase at a given temperature. At a given temperature in a closed system. In a closed system. So students, from this, how can you say vapor pressure means? Listen. Here, if the vapor pressure increases here, means the rate of vaporization is equal to rate of condensation. That results in what? Here, inside this pressure increases. You know, the pressure cooker, if the pressure increases inside the cooker means it will whistle. Means through whistle, that wall, the pressure will came out of the pressure cooker. Correct? So initially here also, the pressure created within this vessel try to come out. Then what happens? It pulls this away. So then what happens? These liquid move from here to here. Pressure increases means this pressure try to pull this liquid. Here initially position is here. Later from here to here. Later the pressure increases. Then here it changes its position from here to here. This much means this inside pressure generated is pulls this liquid down. If pressure is more, then only we can pull that. Understood? So this experiment results or this experiment concludes as there is a vapor pressure in a liquid. Understand? So what is this experiment? Initially liquid is there, when the liquid starts boiling, starts heating means initially the bubbles will form. At that time there is no vapors are formed. There is no vapors means there is no process of condensation. Inner exchange cannot be takes place. Here there is no formation of vapors means it is empty. Okay. Later when it starts boils, then it forms a vapors. When they form vapors, it is a closed system, means the vapors are collected at the bottom of the surface of a lid or any closed surface. Okay. So after some time they cools down, they become condensed. Condensed means cool down. Okay. When they, again, if the temperature increases, it converts into gaseous state. If temperature decreases, again vapors are condensed to liquid state. You know that. Physical exchange. Okay. So here in the condensed mean again they form a liquid and falls back into the liquid. Okay. At that time the pressure exerted. Thermodynamically equilibrium, and the condensation process is equal to vaporization process. At that time a vapor, some amount of pressure exert. That pressure pulls this liquid from here to here. That confirms, yes, there is a vapor pressure in a liquids. Okay, so why this? Another thing is why this one will boil. Why the liquid initially why not it boils? After why it boils? Understand? Initially why not? After some time by increasing, boiling point for different liquids is different. For water, as I told you, pure water it is 100 degrees Celsius. Salt water it is 60 degrees Celsius. What is the difference between that? Okay, if water is there, it should have all the liquid should have 100 degrees Celsius only if it is constant. But particular liquid has a particular boiling point. Understand? What is the reason for that boiling point? Means that depends upon the vapor pressure and the atmospheric pressure. First, I will say what is atmospheric pressure. You know, students, here assume Earth is there. Here it is Earth. Around Earth, atmosphere of different layers are there. Stratosphere, atmosphere, like that. Okay, different spheres are there. In all here, gases are there. Correct? In atmosphere, almost gases, water vapor, dust. Those are there. This is the Earth. This is the layers of atmosphere surrounded Earth. So here, from year to year, students, there is a force. Means this layer exerts some pressure on this layer exerts some pressure on this, and this layer exerts some pressure on Earth. That is what called atmospheric pressure. Pressure exerted by the gases present in the atmosphere on the surface of the Earth is called as atmospheric pressure. Understand? In the atmosphere, gases are there. You know, gases have their own pressure. Vapor pressure I'm explaining means, of course, here gases are there. Whether it is less or more, we don't bother about that. At least it possesses some amount of pressure. Understood? Okay. So this is what is atmospheric pressure means the pressure exerted on the surface of the earth due to the gas present in the atmosphere called as atmospheric pressure. Okay. So when the boiling point will come? Okay. So here, you know, earth is a very vast area. Understand? The surface of the earth is very vast. So to explain the atmosphere, we are considering 1 square unit area like this. It is a cube on the earth. At this area, what is the pressure exerted by the gas on the earth? 1 unit square area. Square unit area, no? Okay. So 1 square unit area, how much pressure it experiences based on the gases of the atmosphere on the earth tells about the atmosphere. Because as I told you, earth has a million of surface. Its radius and curved surface area is big. We cannot easily calculate the surface area on that earth. So for our convenience, they are considering only per square unit area. Per square unit area, how much pressure is there? So in the entire earth, that much of pressure is only there. It is like an average. Understood? Okay. Atmosphere is calculated per square unit area. You may say the pressure exerted by the gas per square unit of an earth surface by the gases of the atmosphere is called as atmospheric pressure. You may say that. Just remember, students, concept is the pressure exerted by the gases of the atmosphere means atmospheric pressure. So when this boiling point when the liquid starts boiling, okay. So here, listen. This is a container means if we kept in a room means out of the container atmosphere will be there. Understood? Here it is. I am considering this. Here bottle is there. I am considering this one as a container. If I kept here, except this system, outer surface, whatever it is, that is atmosphere. Correct? Air is there. There is atmospheric pressure on earth also, on this surface also. On us also, atmospheric pressure is there, correct? But we cannot experience it. Understood? So what I am telling is, if we keep this vessel in anywhere, except this vessel, here inside system is on there, it is closed system. Outside system is other. Outside system is a air. Inside system is a water. Understand? So vapor pressure in water is different. Vapor pressure in outside of this bottle is different. Okay? So when this will starts boils, okay, that is explained by the relation between vapor pressure and the atmospheric pressure. Understand? How? So listen, when the liquid starts boiling, they form a vapors. These are also gases. At the same time, here atmosphere is there. Don't consider this, just consider this. Here atmosphere is there. Same at the same time, the gases of the atmosphere also, understand, apply pressure on these vapors. Understand? Okay. Assume it is a open system or a closed system. Just assume this is an open system like this. Here vapors are evolved. Okay. These exert some pressure towards the atmospheric gases, and these atmospheric gases also have pressure. These exert pressure with respect to this. Understand? If the pressure of atmosphere is there more, then they compress the vapors of a liquid. If the vapors of this liquid is more, this compress the atmospheric gases. Means if pressure is more here, they move towards this. If pressure is more, like diamond from atmospheric gas is more, then they compress. Again the vapors, again they condense into this. You know, gases if they compress means they become liquids. Gases, if they compress, they become liquids. When they compress, when the pressure increases. If the atmospheric gases exert more pressure on this means again these vapors compresses, they become a liquid. So boiling stops. So when this boiling point will occur means when these two become equal. When the vapor pressure of a liquid is equal to the external pressure. Here atmospheric pressure is considered as an external pressure. This one is internal, this one is external. When the vapor pressure of a liquid is become equal to external pressure, then the liquid starts boiling. Understand? This is very important for 1 mark. What is boiling point? Okay, the vapor pressure of a liquid is equal to external pressure. External pressure is called boiling point. Understand? And the temperature is called as boiling temperature. Means the boiling, as I told you, the boiling temperature and the boiling point of water is 60 degrees Celsius means it starts melting when it is at a 60 degrees Celsius. That means at 60 degrees Celsius, the water vapor pressure is equal to the atmospheric pressure. Like that. Understand? Okay. So this is also called as boiling point and the temperature is called as boiling temperature. So students, here in the boiling point, two types is there. One is normal boiling point, another one is standard boiling point. Okay? So one is right here, normal boiling point. Another one is standard boiling point. What is the difference between this normal and standard boiling point? Means, listen, if the boiling point is considered at atmospheric pressure as 1 atmosphere, the unit of pressure of this atmospheric gas is considered as what? 1 atmospheric pressure. Then it is called as a normal boiling point. If it is considered as 1 bar pressure, then it is considered as a standard boiling point based on the unit of a pressure. If the unit of a pressure is atmosphere, that is a normal boiling point. If unit of pressure is bar, then it is a standard boiling point, just a standard boiling. Understand? So example for the students. So listen, here water I consider means normal boiling point of water is 100 degrees Celsius and standard boiling point is 99.6 degrees Celsius. Understand? And always remember the standard boiling point is always less than normal boiling point. The standard boiling point is always less than normal boiling point. Understood? Okay. This is all about vapor pressure. Say that. And here students, you know vapor pressure it is means the unit is either bar or atmosphere or Pascal because it is a pressure. Okay. And remember one thing. If the higher altitude means altitude increases, elevation means height. Okay. If the height increases, then what happens to the pressure? In the higher altitudes, pressure whether increases or decreases. For example, Himalayas. Okay, the peak of the Himalayan, whether the pressure is more or less. Less. Pressure is very less. As we move inside, so higher and higher and higher, if height increases, the pressure decreases. Because as I told you, students, listen, here assume this book is there. Okay, here this is a sheet, sorry, dish, downward sheet, what it is. This one experience more pressure compared to this. Correct? So this will exert pressure on this layer, these two exert pressure on this, these all exert pressure on this, again this all exert pressure on the below sheet. Understand? That means as we go deeper inside, okay, pressure increases. As we move above the sea level, below the sea level, below the sea level, pressure is very high. Above the sea level, pressure is less. Understand? As we move above and above and above, the pressure decreases. Understand? That's why I think so many the hill climbers often they experiences what? That breathing problem. Hill climbers often they experiences breathing problem. And again, if hill climbers are there, they used to wear cylinders. What is the reason for that? If we go higher altitude, then pressure decreases means gaseous molecules are very free. They are not dissolved in the atmosphere. Dissolution power of gases. If what happens? If pressure is less, volume is more. So there they feel a less amount of oxygen for the breathing. If oxygen is less, obviously they feel breathlessness. Correct? So that's why, because of that reason, higher altitudes, so many people, so many hill climbers or mountain climbers wear cylinders because to overcome the breathing problem. Why reason it is? Because higher altitude pressure is less. So volume of oxygen dissolved is less. So the volume availability for the respiration is also less. Respiration is also less. Understand? So as the height increases, pressure decreases means obviously at higher altitudes the liquid boils at a low pressure or a low temperature. Understand? Because at a higher altitude, as I told you, atmospheric pressure is less. That means if pressure is less means very fast this vapor pressure is equal to this atmospheric pressure. So at higher altitudes, the water or liquid or any liquid, not only water, boils at a lower temperature. Understand? So this is the concept. You have to remember this. One marks they'll ask at higher altitudes, what happens to the pressure, what happens to the atmospheric pressure, what happens to the temperature, like that. Understand? Here on this, students, upon boiling point, temperature never affects. Why it affects? To create vapors only. Even they creates vapors. When it starts to boil, when the external pressure and the internal pressure become equal. Internal pressure is the vapor pressure, external pressure is the atmospheric pressure. If both are equal, then they start boils. When the pressure is at the atmospheric unit, then it is a normal boiling point. When it is in a warm pressure, then it is a standard boiling point. And always standard boiling point is less than normal boiling point. This is all about vapor pressure. Understood? So the next one is surface tension. Next one is the second one, that is surface tension. Okay? So students, first I'll explain you. In the last class only I told, if tap is there, okay, from the tap, initially the water droplets are collected here. Later, when the density of the water increases, they form a shape like this. Later, it forms a spherical shape. Okay, what is the form? What is the reason for the spherical shape of the droplets of the water? Okay, another one example is that if the container is there, here water is there, like this. Okay, if we keep a pin on that surface, okay, if we keep that pin without disturbing the layers, then it will float, even though it is denser than that water. Understood? Even though it is denser than that water, it will float on the surface of the water if we put that pin without disturbing the layer surface. If you disturb this, again it will get out. Okay? So students, what is the reason for that? You know, in the water, if anything is denser, okay? If oil is there, water is there. Oil is less dense, having less density than water means oil always floats on water. Understand? Ice cubes are there. Ice cubes has less density than water. So that's why ice cubes always floats on water. Correct? So that is, if the density is compared to pin and water means obviously pin has a greater density. That means it should go inside that water. Understand? But even though it is floats on water, what is the reason for that? That is called as what? Surface tension. How it happens? So listen, if we consider any big container here, so I consider water only. Okay? So students here, the particles are there and the particles are very, water is there assume. If water is there means so many water molecules will be there, not only alone H2O, 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 like so many molecules will be there. So those molecules possess a net charge like this. As I told you, they have a force of interaction in between them. Okay? Next here, the molecules which are nearer to the surface. Okay, here I will write. These molecules which are nearer to the surface. This is the surface. Okay? What they will form? They will rearrange themselves to attain a minimum energy like this. Means the force of attraction at the molecules where they are present at the surface, they experience different force of interaction. Compared to here the net force is 0, but their net force is more. Understand? They have a force of attraction and they experience downward force towards the center. Understand? These molecules here they will move like this means net energy or a net movement is in this direction. Means the molecules of water at the surface experiences a downward force. Means they try to concentrate at the center. Okay, so students assume, I'll write it separate here. Here the molecules are there of water, assume like this, and they try to, here so many molecules are there. Okay, when they come closer to each other, they experience a net downward force. So then what happens? They move downward means, of course, they form a spherical like structure. That's why they become sphere. Why the water droplets form spherical structure means because on the surface, okay, means when they experience a force, they create a surface around them. Understand? That is called as a surface tension. Understood? So why the droplets are spherical in shape means because of the surface tension. Okay, that layer is called as a surface tension. Understand, students? So next, Obviously, it is the property of the liquid. It is the property of the liquid by virtue of which the free surface of a liquid, free surface of a liquid possess, free surface of the liquid possess a tendency to contract, to acquire a minimum surface area. Minimum surface area. Understand what it is? It is the property of a liquid by virtue of which the free surface of the liquid possesses a tendency to contract. This is what I said. These are the bulk molecule. This is the free surface. These molecules try to contract. Why they try to contract? To acquire a minimum surface area. Here they acquire a minimum surface area. Means instead of these students, these molecules try to arrange here in this manner. A thin layer of the molecules. Of course, they form a layer. This is called surface tension. Understand? Here it is considered the unit of the surface tension is students. That is, it is represented by nu. Nu means it is a unit of frequency. You know that? Okay. It is represented by nu, and its unit is Newton per meter or joules per meter square. Newton means joules per meter. So it is Newton per meter or joules per meter square. It is the unit of surface area. So joules means that is energy per area square. Meter square or energy per area. That is called as surface tension or a surface energy units. So what is the surface energy? I read that one also. Surface energy. So students, here as I told you, these have a different energy. This one has a different energy. These molecules have different energy. These molecules, these are the bulkier molecules. These are only countable numbers. Understand? The energy difference between these two is called as surface energy. Understand? What is surface energy means? The energy difference between the bulk materials and surface materials. The energy difference between bulk materials and surface materials is called as surface energy. Here also unit is joules per meter square or Newton per meter. Understand? Okay, listen students. Here, when the surface tension is more, when the surface tension is less. Okay? Assume here surface tension is there, two molecules are. Okay? There is a force of attraction between them. If the force of attraction between the molecules is there more, then the surface tension is more. Means interaction between the molecules is more, then the surface tension is more. Okay. Next, what happens if the temperature increases? If temperature increases, what happens here? These molecules try to attain a gaseous state, they try to boil. Okay, if the temperature increases, they move apart from each other. The force of attraction between them decreases, then obviously the surface tension decreases. Understand? So the magnitude of the surface tension increases with increase in force of attraction. The magnitude of surface tension decreases with increase in temperature. The simple thing. If the molecules are nearer to each other, if they are in a liquid state, they are nearer to each other. When they are nearer to each other means there is a force of attraction between them. If force of attraction is more, means in liquid we can say surface tension. In gaseous we cannot say surface tension. Okay? Liquid is there means of course force is more. If force is more, surface tension is more. If we heat, then it try to be a gaseous state, in a gaseous state. Temperature increases means obviously liquid starts boils and they form vapor state, right? So at that time, the force of attraction decreases. That means what? Surface tension decreases. Surface tension is only for liquids, not for gases. Just understand the concept. If the temperature is more, liquids start converting as a gas. That means obviously surface tension decreases. For gases there is no surface tension. For solids also there is no surface tension because these atoms in a solid they are already tightly bounded. There is no arrangement of atoms towards downward, towards backward or forward, above. It cannot take place. So in solid and gaseous, there is no surface tension. Only liquids there is a surface tension. And they'll ask the reason. Reason? What is the reason for the spherical shape of the water droplets? Just you have to write due to surface tension. Understood? So this one all about surface tension. And the last property is that is viscosity. That is viscosity. So students, to explain this viscosity, we have to consider the liquid layer by layer. Okay? Here one layer is there. Here another layer is there. Here another layer is there. Like layer. First layer, second layer, third layer. Okay? Liquid is considered as layer by layer. Understand, children? So as I told you, if the slant surface is there, here land is there. Okay? If we observe a time taken for the droplet of the oil and droplet of the water to reach from this position to this position means water reaches faster than the oil. Understand? If we count the time taken for the flow of this water droplet and oil droplet from this position to the land downward, this position means of course the water flows faster. Okay, so what is the reason for that? That is called as viscosity. Okay, why water flows fast rather than oil, honey, anything. Okay, that is called as viscosity. What is the viscosity means? First I'll write here the tendency or the resistance. The resistance to the flow of a ball layer by the below layers of liquid. Resistance means stop. To what? The flow of a ball layer. So this is the ball layer. Understand? So students, I write here. Listen. This is the slant surface area. Okay, here Number of layers are there of liquid. So this is the above layer. Always when it flows means only if you drop this droplet like this, here the below layer cannot move. Only the above layer density at the above layer increases and this become bulker and move forward like this. Correct? If you observe droplet or anything, if you keep it in like this, then here the below surface won't experiences the flow. Understand? The above layer, the drop by drop by drop, it increases. If you add students in the slant surface area, okay? If you add drop by drop, initially it becomes bulk, means density of water increases. Later it flows. Slowly if you add drop by drop, I'm telling. Understand? So that means the above layer movement takes place, not the below layer. That is what viscosity. Understand? The resistance to the flow of above layer by the below layers. That is called as viscosity. Understand? So what happens here means there is, if the next layer which is directly contact with the surface, the layer which is directly contact with the surface, this one is stationary. Okay, the layer which is directly contact with the surface is stationary. It cannot be moved. If the droplets of water move from ear to ear, also this area gets wetted. It shows the movement of the droplet as water is moved from ear to ear. Like, what is the reason for that? Because the layer which is exactly directly come in contact with the surface, it is stationary. It cannot move. Understand? That means that's why we can easily see the path how the water droplet flows. Like this is that. How in winter season on the glass wipers, the water will move like this. Okay? So that shows what? The path from where, in which direction the water flow takes place. Okay, what is the reason for that? Because the lower layer of the liquid is stationary with the contacted surface. Understand? This is called as viscosity. So students, initially assume this is layer dz, this is layer du. Means initially the layer starts from dz changes to du assume. Initially it is dz layer, it changes to du. Then velocity gradient that is equal to du by dz are directly proportional to du by dz. Velocity means distance by time taken. So here from one layer to next layer, how many distance is covered at a certain time? Understand? That is called velocity gradient. That is represented by v. V is directly proportional to du by dz. Okay. So students, you know that. Sorry. Okay. This is considered as what? Force. Velocity gradient is considered as force. Okay. Next. Take here. Force is directly proportional to acceleration by time taken. Correct? Acceleration by time taken. Your time I am considering as 1 because you need to time. So that means force is directly proportional to area. So compare these two students, you get force is directly proportional to A into du by dz. This is changing what? Surface areas and changing the layers. Next, to remove this proportionality, we can add neta. This is right in this manner. A into dz by du. This is the equation for a viscous force. Understand? So this one is called as velocity gradient constant. Understand that? That one is called as velocity gradient constant. So students, in all this, you have to remember only one thing. What is viscosity? And what is the effect of temperature on viscosity? Listen, if you eat this oil, it becomes very, sorry, it flows very fast rather than water initially. For example, if you cool down oil, okay, then the flow of oil, cold oil is very less compared to hot oil. You know that if the temperature increases, then the force between these layers decreases. Yeah, this one. The force between these layers decreases. That means if the temperature increases, viscosity decreases. Reason is the force between the layer decreases. If there is no force, they won't stop the above layer from flowing. Understand? So if the temperature increases, surface tension also decreases. If the temperature increases, viscosity also decreases. But if the temperature increases, vapor pressure increases. Understood? Okay. This is all about the properties of liquids, and this completes the chapter states of matter. Okay? Thank you.